Hello and welcome to the Sidewinder conveyor design tutorial series. My name's David Cruz, and I'm essentially going to step you through a number of tutorials that we've put together. The reason behind these tutorials is essentially just to give you a quick introduction to the Sidewinder software, maybe cover a few topics that you might have missed in the user manual or with the online tutorials, and you might also just see some tips and tricks of ways that you can do a few things that, like I say, you might not normally pick up reading the user manual. So this first tutorial is just an overview of the software itself. Once you get the CD-ROM, put it in, install the Sidewinder software. Be sure to also install the Sentinel USB key driver. You need that installed as well to run the software. Plug in your USB dongle and fire up Sidewinder, and you'll come to the screen we've got here. Now from here we can go ahead and open a new file, or in our case we're just going to go ahead and start with a new file from scratch. What you get is this easy conveyor input window, and all this essentially is a list of some different conveyor profiles that we've put together, be it a drive at the head with a gravity take-up, or perhaps a tail drive or decline conveyor, tripper drive, dual tripper, feeder belt, so on and so forth. Just some easy starting points that we've already entered the geometry for you. Once you get more familiar with Sidewinder, you'll probably just start with an empty conveyor geometry and you'll just put your whole conveyor in from scratch. But for now, we'll go ahead and just pick basic conveyor. And we can go ahead and select a material type as well here. Let's just pick copper ore. Maybe we'll say 1,500 tons per hour. Let's say 350 meters long and 20 meters of lift, just to enter some data. So once we've done that, we'll go ahead and click the continue button here, and you can see Sidewinder's generated a profile for us. 350 meters long, 20 meters of lift. And this is essentially where we can enter our profile of our conveyor. We can also enter our idler information and so on and so forth. We'll discuss this in the next tutorial. For now, let's go ahead and run the calculations. And we can run the calculations simply by clicking the little calculator here. And that brings us to the main window. We were just in the conveyor geometry window, and once we run the calculation, it'll put us on the main window. And what the main window consists of is essentially a number of different inputs. And this is a window you'll work in quite a bit. The material, properties, take-up information, motor, brakes, backstop, pulleys, belting, idler, you name it. And the window down here is all output information. Project, each individual load case. In our case, we've got an empty and a fully loaded belt, but we might have inclines, declines, different material types, different tonnages, so on and so forth. Cross-sectional view of our material, and we can see we've left a number of things blank, and Sidewinder's automatically selected a 1,000 millimeter wide belt running 2.2 meters per second, and idlers, 35-degree trough idlers, 152 for a roll diameter, so on and so forth. But essentially this is all different output information, be it on belting, idlers, motors, backstops, material trajectory, so on and so forth, the loading of the conveyor. So I guess we've this button here, going back to our toolbar, solves the calculations. We've got our main window we were in, our geometry window, and also this first window here is our project information. These three buttons are pretty much the main input windows in Sidewinder. The project information is essentially just that. It's kind of general information about the conveyor system. The conveyor name, designer, location, what type of solution methodology you're going to use, and most importantly, what load cases you're going to look at. All conveyors, you'll look at an empty and a fully loaded conveyor. Typically, you might also want to look at, all right, what happens under high friction conditions, i.e. what happens in the winter time. And that's the high friction is related to what we enter on this frictional condition tab right here. In other words, our high friction will be, again, our highest power consumption, which would be our lowest temperature that we expect, in which case we might also reduce the mechanical efficiency, i.e. more power consumption, increase our accessory losses, so on and so forth. For the low friction case, maybe you've got a decline conveyor, in which case you want to analyze the lowest friction, or i.e. the highest regeneration of the conveyor. And Sidewinder is not just limited to two. By default, we can click this incline and decline, which will automatically load only the incline sections under high friction, i.e. like our worst power consumption, and our declines under our low friction condition. Alternatively, we can also add custom cases. For example, I could say fully loaded, let's say normal friction, and let's say 120% of our current tonnage. So I could say that this is loaded at 120%. So rather than having to make a separate file and look at those tensions separately, we can include those right in our design calculation. Or perhaps we wanted to say fully loaded, and maybe for some reason we're going to have a second material set rather than just copper. Maybe we're running a lot of times in your manufacturing plants you might have different material that you're running on the same conveyor, so you can go ahead and set those. You could run it at different speeds. Maybe at 120% you're going to increase the speed to 3 meters per second, and for this other material you're going to run it at 4 meters per second, or whatever it may be. So let's just go back to just our basic cases here. So in this case, let's see, we've got an empty case, we've got fully loaded low friction, normal friction, and high friction. We've got inclines high friction and declines low friction. When I go ahead and click that run for the calculation, you can see we've now got all these different load cases. Now this is a pretty simple conveyor. We've only essentially got one incline section, so I mean our decline is essentially the same as our empty belt. You can see where this would be very powerful to look at these different situations. Again, I can go to my case, individual cases, and look at what the power consumption here happens to be. For the normal friction, 130 kilowatts. For the low friction, it's 119 kilowatts. For the high friction, it's 136 kilowatts. Or on my project case, I can just see it summarized right here, what the different power consumptions are. So again, just we don't want to get into too much detail here, but essentially these are our three main input windows. Our project information, again project, load case, frictional conditions, and there's also this design criteria. This is very powerful. As we just mentioned, a lot of things for Sidewinder we never entered the belt width or rating or any of that, but Sidewinder automatically picked a lot of that, and how it selected that was essentially based off our design criteria. Now, for most conveyors, you probably won't be changing this. I mean, the default for safety factor for a fabric belt example is 10 to 1. Steel cord is 6.67 to 1. These are commonly used values. Friction factor for rubber lagging is 0.28. Ceramic lagging is 0.35. Now, some designers might push this to 0.3 or maybe even 0.35 for rubber lagging and 0.4 or 0.45 for ceramic lagging. Those are up to you. But the default values are fairly good and what we, I guess, recommend. Again, the geometry, the next button was our geometry tab, and the third button there was our main input window with our summary output. This other button here is for our detailed output information. What that essentially is it's very similar to this output summary, only it just essentially gives you the full window. It also has a little bit more detailed information. For example, if I look at the shafts information, I can look at each individual shaft and what the safety or the stresses are at each location along the shaft, versus on the main page shaft it just boom, here's just a summary. That's all you get. Here's what it's selected. Here's your safety factor, the deflection at the hub, and the bearing L10. Just essentially that information, versus here it shows you just more detailed information on it. These first four buttons are fairly self-explanatory. Open a file, save the current file, print the file. This is quite nice. This converts to units. So if we look back at our main page here, and let's go click on our case information, we can see we're working in metric right now. But if I just click that, it automatically switches all our inputs as well as all the outputs to English units. So the belt rating is changed to PIW, the belt speed to feet per minute, belt width to inches, so on and so forth, which is quite nice as well. We can just simply click this and it automatically switches all of our input and output units. Now, one thing to just bear in mind, for example, like the belt width here, it's 39.4. Well, I had picked a 1,000 millimeter belt width. Now, if I switch this to English units and I rerun the calculations, you'll see it'll pick a 36-inch belt. In other words, when you run the calculations, whether you're in metric or English, it's going to pick values that correspond to what would be used in that system of units, which is also very nice as well. So that pretty much just wraps it up as a very quick overview of the software. Like I say, in the following tutorials we'll get into details of each individual component and each of the inputs. But for now, that pretty much wraps it up.